Hi, everyone, and welcome to our webinar, The Machines Aren't Out to Get You. Today, we have Jerry Foster with us. He is the Chief Technology Officer here at Plex, and he is also a co-founder of our company. He is going to share real-world use cases, data, and tips for using artificial intelligence in your manufacturing operations. If you have any questions, please put them in the chat area as everybody's on mute, and there will be a quick time for Q&A after Jerry's presentation. All right, Jerry, it's all you.
All right, awesome. Thank you, Rhonda, and appreciate that intro. And good morning or afternoon or evening to all of you, wherever you're at. As Rhonda said, my name is Jerry Foster, and I'm the CTO, one of the co-founders at Plex Systems. And I'm so excited and honored that you would take time out of your busy schedule and spend some time with us today as we take an entertaining look at how you can utilize artificial intelligence for your manufacturing operations. Our agenda today is broken down into 4 parts. We're going to take a look at the intro, have an intro and take a look at the origins of artificial intelligence. And you might be asking, why are we going to take a look at the origins of AI? And that's because my sense is that for most manufacturers, AI is sort of out there, right? We have a good grasp of many of the Industry 4.0 technologies like IoT and 5G and 3D printing. Those all seem close to where we're at. But artificial intelligence is kind of like this fuzzy area, and we're not quite sure why everyone's talking about it. And I believe a basic understanding of how and why it's so powerful will give you the confidence to take advantage of this amazing technology. Then we'll hit some manufacturing use case examples. We'll talk about some myths that you may have heard and what the actual facts are behind that, and then how you can actually get started in your facility. So just a little bit about expectations so you can understand what this talk is and is not about. My talk today is more of an overview as opposed to a deep technical discussion. There's not going to be any wordy slides with tons of bullet points or code examples. There's plenty of webinars and articles out there if you want to geek out on that. I just want to give an overview and give a kind of just a real use case for using artificial intelligence in manufacturing. So if you are building neural networks and writing AI routines, this is probably not the class for you, and you can head for the exit, virtually speaking. But for the rest of us, I'm assuming all of you are manufacturers or in manufacturing. Hopefully this will be useful. So just a little bit about me. I first got my start when I had long flowing locks of golden blonde hair, working in the computer department for a forging facility just outside Detroit, Michigan. It was dirty and loud and hot. I remember that first time walking by a 2,000-ton press, and that ram came slamming down and on a molten hot piece of metal, and just the feeling, the ground shaking, and a feeling in my chest, and like, this is awesome. This is where I want to spend my career. I would go home with graphite in my hair at the time and oil on my clothes, and my wife was like, I thought you were programmed, right? I can't figure this out. You're filthy when you get home. So we built an MES product that would control every aspect of the manufacturing process, and then we started our own company, Plex, selling that product. And then last year we were acquired by a small company. You may have heard of them, Rockwell Automation. And so basically I've spent my entire career at this intersection of manufacturing and technology. Specifically, what technology can we bring to the shop floor that will make our customers' lives easier and more efficient and safer and more profitable? So speaking of cool technology, did anyone ever watch Space 1999 as a kid? I love that show. There's these iconic spaceships and all these gadgets, and I always thought, man, it's going to be so freaky when we get to 1999 and have all these cool things, right? Well, it's 24 years later, and we don't have spaceships that are flying around between planets at all. Although we do have smart toilets, so that may be a nice trade-off. I'm not sure. Just by the way, the headline on this article where I read about the smart toilet was Kohler launches a smart toilet with Alexa inside. So all I could think of was poor Alexa. She's inside the toilet. I don't know if that's a good place to be. But anyways, the point is technology seems to be moving so fast with so many new technologies. But are they that new? Like take, for example, the topic of our talk today, artificial intelligence. It's a technology that seems new, but it isn't. So we're going to look at what it is, where did it come from, and why is it such a big deal now, and most importantly, what does it mean for manufacturers like yourself? A good place to start is just a definition. What is artificial intelligence? Merriam-Webster has a couple applicable definitions here. A branch of computer science dealing with the simulation of intelligent behavior in computers, or the capability of a machine to imitate intelligent human behavior. And look at these two words, simulate and imitate. we're putting together systems or software or machines that give the appearance of having intelligence. Basically, the ability to make decisions seemingly on their own. Now, our story actually starts in 1956 at Dartmouth University, where a conference was put together by some of the biggest thinkers in computer science. These guys are the founding fathers of computer science as we know it today, and they met to discuss how machines could simulate intelligence. Now, I'm not going to go over all these guys here. They are the founding fathers of computer science, but I did want to point out this dude on the left with the goofy smile. I don't know who he is. I just know he's not wearing pants. I can't figure that out. I was wondering that conversation, Mom, I forgot my pants. But don't worry, honey, it's a bunch of nerds. Just wear your underwear. They won't even notice. But anyways, this workshop is where the phrase artificial intelligence was first coined. That's 65 years ago. This technology is older than me and probably most of you. So at a very basic level, artificial intelligence can be broken down into two parts, all right, automation and machine learning. Now, automation, you guys all know what that is, right? It's a machine that does a repetitive task, something that computers and robots are very good at. Benedict Evans gave a talk about this a few years ago, and he explained it this way. Ever since the 1950s, when we think of automation, we envision this humanoid type robot like Rosie the robot here from the Jetsons cartoon in the 60s. She's model XB500 if you were yearning for that information. But Rosie does the laundry, she washes the dishes, she cleans up after you, gives you a little foot rub before you retire. But even today, we have this vision of a general purpose humanoid robot that does all of our chores. This is what we really want. But this is what we got. This is the Bendix DRS. It's the first electric washing machine that came out in 1961. That was 60 years ago. You know, surely, Jerry, we have a general purpose robot now that can do all those things and wash our clothes, right? No, actually, we have this. We're like, oh, well, not much has changed. It doesn't seem like anyway, at least as far as purpose is concerned. But make no mistake, what we have now is a robot. Washing machines now have computer chips, programming algorithms, sensors, electrical components. They are the definition of a robot. And all these things work together to automate a repetitive task, washing clothes. It is a single purpose machine. Now, I can get robots that'll vacuum, mow my lawn, or remove snow, but the key is I have to get an individual robot to do each one of those things because they're all single purpose. And this is where automation continues to go deeper and smarter, but still narrow. Now, the flip side of that is machine learning. That's the second component of AI. And basically, machine learning are computer algorithms that automatically improve through experience. Now, what is it exactly that they are improving? Well, the ability to recognize patterns. And you might think, well, how is that useful? Well, think of cat pictures, right? Can you imagine the internet without cat pictures and kittens and all those cute, cuddly creatures? How does Google know how to identify a cat in a picture? It doesn't have a picture of every single cat in the entire world, but we have given it enough pictures and said, this is what a cat is, and it has enough of those to start to recognize on its own the patterns and characteristics that identify a cat. Now, this slide is just an aside. I just thought it was fascinating just to show over the years how good this pattern recognition capability has become. A deep learning AI model recently was trained on 85,000 eyes, and it can tell the difference between male and female eyeballs with 87% accuracy. I'm like, okay, well, that's interesting, but here's the kicker. Scientists are currently unaware of any distinguishable differences between male and female retinas. But somehow there's a pattern in there that the algorithm has figured out. I just find that absolutely fascinating. So back to our main topic here. So we have automation and machine learning. Now, if I put those things together, I have something really interesting, the ability to automate that pattern recognition. So I don't have to manually program an algorithm to find dependencies and patterns in data. It can now do that on its own. So why is this a big deal? So this is my textbook from Computer Science 490 Artificial Intelligence class. In fact, I still have the book. It weighs like 32 pounds, but it starts with a very interesting point. When we hear artificial intelligence, we think of something clever, something very futuristic, and it is, but maybe not in the way we would expect. See, if I asked you to calculate the answer to this equation without a calculator, without a phone, without your computer, you could probably do it. You grab a pencil and a really big eraser and it's going to take you a while. And then if you wanted to check your work and work backwards, it's going to take you even longer. So maybe an hour or 2 or 3, but you might be able to figure it out. But if we were in a room, all of us together, all 200 of us, and I asked you to get up and walk across the room and have a conversation with someone on the other side, most of us could do that without thinking. Unless, of course, you're an engineer like me, and then you'd be like, what, you want me to talk to someone I don't know? Are you nuts? But anyways, computers are just the opposite, and this is what's fascinating. I can throw at a computer nearly any mathematical equation, and it's a trivial exercise to return the right answer in milliseconds. But talking, seeing, listening, these have always been very hard for computers. And think about that for a second. For all the things that computers can do, the most basic of human type things that we learn to do at 3 years old, machines simply throw up their virtual hands and surrender. Do you remember that scene from Star Trek 4 where the crew goes back in time to the 80s? Because it's the best decade ever. And Scotty tries to use his computer and he just walks up to it and he says, computer, computer. And someone hands him a mouse and says, no, you need to use this. And so he picks up his mouse and he says, hello, computer. And at the time we all laughed and laughed and laughed because everyone knows you don't just speak to a computer and have it give you an intelligent response. Really? Because now I talk to my phone every day and it answers and no one even blinks. Not just my phone, I can speak into my living room and the soothing female voice answers my questions and even tells me dad jokes or the weather, or my TV remote, or even my watch. I love the example here. It says, Alexa, remind me to go for a jog at 1 p.m. My reminders are more like, Alexa, remind me to pick up a party-sized bag of M&Ms at the store on my way home. So I'm probably not using my Fitbit as intended. But think about this for a second. Think about the task of listening. The computer has to learn from a stream of audio what is language and what is not. So it has to filter out background noise like traffic and music and the dog barking. And then from what's left, it has to learn where the words are. Because when I speak, I'm not pausing between words, so it has to figure that out. And then you throw in dialect and accents and slang. The combination of possible variations in a single sentence is immense. And historically, no one had enough storage or computing power to even attempt to train a computer to learn such a thing. And this is why artificial intelligence, even though it's 65 years old, has been on the fringe for so long, because the computational power and the amount of data required to come to interesting conclusions was only available to those with big pockets, the government, some universities, a couple corporations. So that begs the question, what happened between Star Trek 4 and today, or even on a greater picture, what happened from the Dartmouth conference and today, 65 years ago? Something fundamentally changed recently in the last 5 to 10 years. If we were in a room, I'd ask you to kind of throw out what your guesses were on what changed, but we're not, so I'll just tell you if you hadn't figured it out already. It's the cloud. The cloud made a difference because we now have a platform on which we can store a ton of data and analyze it with unlimited computing power. And we can do so at a fraction of the cost due to the economies of scale. And the way that all comes to fruition is right here. Suddenly, I can automate that pattern recognition. Remember, that's what AI is, automating pattern recognition, but I can now do it at scale. And that changes everything. I can now start asking interesting questions that have weight, like, am I gonna crash? Or what are the odds that I'm gonna get heart disease? Or really important stuff like, what should I watch next on Netflix? The cloud and AI technologies have given us the ability to ask meaningful questions about basically any data set you can get your hands on. Excuse me. Basically, the cloud has democratized AI, and that means you and your manufacturing facility can now participate in this capability and at a scale and a price point that's appropriate for you. This is really profound in its implications, because now you can start asking questions that have weight about your manufacturing data, questions that matter to you. Well, how does that play out? Well, think of all the data sets that are sitting in your organization. Maintenance, production, shipping, tooling, EDI, HR, all these data sets you have. Now let's talk about one particular data set that you're probably familiar with, downtime. You're like, oh no, we don't have a problem with downtime. Well, okay. Hypothetically, if you did have a problem with downtime or your machines ever went down, you probably want to record that, right? So you have an idea of what's going on. So you probably have a system to record downtime. Now you might be using a manual system like a spreadsheet, and you might have been collecting this data for a while. So let's say you have one spreadsheet per shift. After about 5 years, that's 5,500 spreadsheets. How do you analyze thousands of spreadsheets or even thousands of rows in a single spreadsheet to make sense of that data? And you might be like, oh, no. We're much more sophisticated than that, Jerry. We don't have a spreadsheet. We use an MES or an IoT system. And that gives us some really nice analytics, unlike your spreadsheet example. And my response to you would be like, well, la-di-da, good for you, because I have a question for you. What do you do with that? What do you do with this chart that you see on the screen right now? Now, it's good data. I can see several areas that I have to be concerned about with material shortage and missing operators, stuff I need to investigate more on. But now what do you do with that? I would probably go talk to my operators. I might go talk to my forklift drivers. I might observe for a while. Hey, what's going on with the material shortages? And they'll give me all sorts of excuses, reasons, and I'll have to track down and determine if those are truthful. See, a chart like this, it only tells me where to start asking the questions. And that's not a small thing. I don't want to minimize that. It's a huge step towards solving the problem that you might have had before. But it only tells you where to start. It doesn't give you true insight into the actual problem. Now, let's say instead, we took all this downtime data, no matter the source, whether it's your spreadsheet or your MES or your IoT, wherever you're getting it, and you combine it with some other relevant information, maybe operator info, inventory data, HR data. And maybe if you're just a little bit more advanced, you can pull in some external data sets like the weather or holidays or even health department data, and then funnel that through an AI model and let it recognize patterns that we could never have found on our own. It's like having an army of interns combing through the data. And so, for instance, it might say, hey, look, I found a correlation between material shortages and operators on shift who are trained by Joe. Now that's a link you had a good chance of missing just looking at that report or talking to your operators. This model, this AI model, provided actionable insight by uncovering a relationship that was hidden deep inside the data. And now everyone loves our new AI system, except Joe, of course. Now that was sort of a hypothetical scenario, kind of just trying to explain in a familiar situation how AI can benefit you. But let's take let's dive deeper into a couple of actual use cases that I've seen. There's dozens, and I'm just going to pull out a couple that you might find interesting. This is the Metropole Parasol in Seville, Spain. Now, this architectural construct could not have been done without a process called generative design. Basically, it's a system that rapidly offers up unique styles and shapes until the architect says, that's the one I want. But with the addition of artificial intelligence, it's starting to have some profound implications in manufacturing as well. See, when an engineer starts a project for a brand new part, they have to go through this tedious design process. How do I make this part with all the various design constraints that I know I have to deal with? Things like, what are the spatial requirements and what raw materials do I have available to me? What are the manufacturing methods available? What are the cost constraints? There's so many things that I have to deal with. And a lot of that is just a manual process that relies on experience and tribal knowledge. And then once the engineer has finally built the part to his satisfaction, they'll often take that design and put the part through a process called topology optimization. And that process takes a single design, and that's key, a single design that the engineer built, and whittles away the material to provide an optimized version of that known solution. Generative design takes that concept and turns it on its head. Instead of taking a single design and optimizing it, it takes my original design goals, all those constraints and considerations we looked at last slide, materials, manufacturing methods, it quickly permutates, takes all those and then it quickly permutates through all possible designs, optimizes each of those, and then presents them to the engineer, who can then choose which ones he wants to work on and make further adjustments. And through that iterative process, the software uses AI to learn which patterns work under which conditions and which don't. This drastically reduces the design and prototype phase of any project from months to weeks, maybe even days. Also, while giving me dozens of options that I would have never figured out on my own. These elements right here, they show the progression of a generative design process. The cool thing is they can all handle the exact same structural load, but that object on the far right, it uses less material, it weighs less, and it's much cheaper. But how do you fabricate that? It looks like an alien just like vomited that, like, oh, here you go, vomit that on my desk. I can't forge it or extrude it, can't stamp it or mold it. Because why? Practically every fabrication method we know takes a block of steel and removes material to get to your part. But you know what? I can 3D print it with a 3D metal printer. See, because 3D printing starts with nothing and adds only the material I need to make the part. And I love this about artificial intelligence. I can take my artificial intelligence methods, I can apply them to an older concept like topology optimization, create a brand new category called generative design, combine it with a 3D printer, and I have a whole new way of doing business. That's why I often call AI a boosting technology, because it boosts or augments existing technology that you already have. And there's a number of forward-looking companies, Airbus, Under Armour, Stanley Black & Decker. They're now using generative design and AI to design and manufacture solutions that the human mind could never conceive of on their own. The results are kind of organic looking, which is kind of unique and different, but they're very powerful. All right, our third and final use case. This involves one of BMW's press shops in Germany. It was in a city whose name I can't pronounce, but they were struggling with pseudo defects. See, they were trying to identify cracks in sheet metal. And it was basically using a standard camera system that was not AI based. It was just a brute force image system that would tag potential defects. However, the system would flag deviations that were simply dust particles or maybe oil residue that was just a normal byproduct of the manufacturing process. And so they spent a huge number of cycles manually weeding out false positives. So they finally decided to implement a brand new AI-based vision system. And how that works is an employee would tag photos, about 100 each, the good, the dust, the oil, and the bad, and they fed it into the system, which used AI to automate the pattern recognition. Just like identifying cats, it learned how to identify actual cracks in the sheet metal. Now, after some tests and just a few tweaks, that camera system can tag actual defects with real time with 100% reliability. 100%. And they removed all of that manual process. All of that waste is gone. All the people that had to be involved with weeding out those false positives, gone. Moving on to more value inducing things. Now you might be like, okay, Jerry, I get it. I'd love to have something like that in my plant, but yeah, I'm sure it's expensive and BMW has resources I don't have. I don't even drive a BMW. But that's so exciting about what's going on right now. And we're going to circle back around here in a little bit and I'll talk about this again. So just hold that thought. In the meantime, we're going to kind of move on from the use cases and let's talk about a couple myths that you might want to kind of have discounted that you may have heard that I have heard quite a bit of, right? First one is this. We're all a little nervous, right? AI is going to take all of the jobs. All the automation is going to take everything. Or worse, it's going to go all Battlestar Galactica on us, right? I've been hearing this for 10, 15 years that automation and AI is going to destroy the economy. And I've heard articles like this, you know, we're going to lose a ton of jobs. And then articles like this, oh no, wait, we're going to gain a ton of jobs. And like, which one is right? Now, here's the interesting thing about where we're at right now. A couple of years ago, I would have said, looking at the slide, they're both right. Because history has followed a fairly consistent pattern with technology disruptions. And normally that would have continued here. And by that pattern, I mean a large number of people will lose their jobs and have to be upskilled in order to stay relevant. But a large number of new jobs are created with an entirely different skill set. And I still think that will happen, and it's happening maybe a little bit, but really only half of that is happening at scale right now. And the half that's happening is new jobs are being created with a different skill set. But because of where we're at in history right now with this unprecedented job shortage and labor workforce shortage issues, a lot of what's happening with automation and AI is simply filling the gaps of workers that we can't get in to do the jobs. So right now, there are some people that are losing their jobs, obviously, to automation, but not nearly as it would have been the case if we weren't in this current situation that we're in. So that's not going to last forever, but for right now, it's almost like thank goodness for automation and AI, so that we can actually keep the wheels turning and keep things parts being made and get things going, right? So I think that'll continue for the foreseeable future, but then I think this pattern will catch up. All right, myth number two. Myth number two is you need a data scientist. You can't have an accurate and good AI system if you don't have a data scientist. Now, that's a myth, all right? Because the reality is there is a spectrum across the AI application landscape, which in broad strokes includes data scientists, programmers or engineers, and business analysts, or whoever the equivalent is at your company. Now, we need our PhDs and our data scientists with deep expertise in these sophisticated techniques, because they're doing the hard work. They're solving our hard problems, and they're usually at large organizations that can afford them, that have huge AI initiatives that attract them, and that's fine, because there's a rapidly expanding set of powerful and easy to use AI ML services and applications that can be used by engineers and analysts and just about everyone at your company. So the ability to do AI effectively is quickly shifting to the right on this graph, where most of us are doing business. There are so many tools available, combined with the cloud, just about anyone can get into the game. Just as a personal example, how that played out at Plex. A while ago, we set out to make our mobile software work on wearable devices like this RealWear HMT1 helmet here. But we also want to take advantage of voice recognition for hands-free use of this device. Now, here's the thing, Amazon and Microsoft, they've already solved that tough problem of voice recognition and noise canceling technology. They have PhDs in linguistics and complicated computer algorithms figuring that out. We didn't have to do that. I didn't have to hire a single PhD or a linguistic expert or any of that. All I had to do was develop a voice interface to the business application using their provided services. Fairly easy for any of my programmers to do. So we're taking existing AI tools and configuring them for business value. No data scientists needed. All right, myth number 3. So you might be sitting there thinking, finally, a technology I can use that will make sense of all of my crappy data. Let's just dump all this data in one big bucket and let the AI algorithms sort it all out. Well, I got bad news for you. That's not how it works. Now, it's true. The single most important tool for AI is data, but it has to be the right data. And to me, the right data has 3 characteristics, all right? Your data must apply to the problem you are trying to solve. When we first started our AI initiatives years ago, I was actually surprised about how much of an art this is, combining the right data sets for your AI algorithms to arrive at solutions that make sense. For instance, if I have too many data points involved, I can't come to interesting conclusions because there's too many dependencies that make any sense. But if I have too few data points or too few categories that I'm drawing from, I'm basically leading the witness because it can only come up with a very short set of patterns, 1 or 2 patterns that it finds, right? So being able to find the right mix there of data and how much it really takes someone who understands the data and understand what data is relevant to be able to put that together to come to interesting conclusions. And that's why you need someone, or better yet, a set of someone's on your team who understands those data sets. Second thing is your data has to be accurate. Now your data is coming from a variety of sources, right? Sensors, industrial equipment, MES, CRM systems, accounting, the list is almost endless. But we need data that is free from error and comes from reliable sources. The most powerful AI routines in the world are helpless with bad data. You've heard garbage in, garbage out, garbage out. It's still true. Nothing's changed about that. So this is why when you start your initiative, you'll have your best success starting with data sets that you know are the most precise and accurate. Now, because you need relevant and accurate data, it needs to be curated. You need somebody, hopefully more than one, on the team who has domain knowledge about the problem and the relevant data. We've already spoken about this, right? You need team members that have a good sense of what data is applicable to the problem and where that data can be found. So while you don't need a data scientist, you do need someone involved in the project who understands your data. In fact, many forward-thinking companies are forming data governance functions in order to formalize this vetting of the data. They're building functions whose only purpose is, hey, we are trying to get ahead of the game. Since AI is becoming so prevalent and we know we need good data sets, we are taking a look at the data we have. How can we make it better? Where do we need to improve it? How can we connect it? And they are forming those teams to actually give them a leg up on their pending AI initiatives. All right, so those are 3 myths. I hope we discounted those and got you on the right track there. So now let's kind of get into where this really might, the rubber might meet the road for you. How do I get started? Jerry, this has been awesome. This is so cool. How do I get AI into my organization? You've convinced me of the power of it and what we can do. How do I get started? But I'd ask an interesting question to start with. What's your core business? What is it that you do really? Is it this? Or is it this, right? No, it's the first one. You make stuff. You're not big data specialist. You shouldn't need to be, right? You shouldn't be. You're not in the business of IT. You are in the business of making stuff. I remember way back at the beginning of my career when I worked in this forging company as a programmer, and I was out in the plant one day, and I was working on some program next to a press, and our CEO and president came out. His name was Richard. He's kind of an imposing figure, and he came out and he's walking right towards me, and I saw him coming at me, and I thought, he must be coming out to tell me, Jerry, you're an awesome programmer. I'm so glad that we hired you. You've done great things for the company. But when he got there, he crossed his arms and he looked at me, and he looked at the press that was going up and down, and he looked at me again. He said, Jerry, I don't care what you do, but don't screw up that press, because if it's not making parts, we go out of business. And then he walked away. I was like, oh, all right. But it always ingrained on my head the importance of making sure parts are being made. This is what we do, all right? But here's the thing, your IT and OT vendors, they're in a different business. It is their job to know that stuff. So make it so when it comes to AI. Ask them. This is one of the first and easiest things you can do to get started with AI. As you go about purchasing or implementing your solutions, whether it's an MES system or a quality system or PLCs with sensors, whatever you're putting in place, make sure your vendors are building AI capabilities into their workflows that will give you deeper insight into the data that is being collected. Any technology solution coming out now should be building AI routines into their core product. So that question should be part of your discussion with the vendor, should be part of your RFQ. For instance, one of our products is a supply chain planning solution. It's called DemandCaster, and it gives our customers the ability to plan and forecast required inventory levels that are going to be needed down the road with accuracy. The question is, what if we could improve the accuracy of our forecasting module? Would that not help our customers with this current supply chain volatility? So we built an AI model using historical sales data and let the model determine patterns in the data and fed those back into the forecasting algorithms. The result? Our first implementation shows a 5 to 10% improvement in forecasting accuracy. You might be thinking, well, it doesn't, I mean, it's okay. It doesn't seem like a whole lot, except when you consider that each percentage point of improvement leads to a 1 to 2% reduction in inventory. So that's a 10 to 20% reduction in inventory to meet the same level of orders. That is amazing. Now, our next step, we're going to add some additional data points like pricing and point of sale to that AI model. And we expect another 10% reduction in the inventory levels. And the result of that, happy customers. Now, our customers, they don't need to write forecasting AI algorithms. They just need to make sure we do. And you can do the same thing. All right. All right, moving down a little bit on the hands-on approach here. I'm seeing a lot of powerful all-inclusive solutions that are now being made available that significantly minimize the hassle and the know-how that's needed to implement an AI solution. Now, these are more hands-on, but they still hide much of the complexity. Now, remember that AI vision use case at BMW that we discussed? This is the picture here is a Deep View Vision AI system. We're not affiliated. I'm not affiliated with them in any way. I just stumbled across them at a conference last summer, and I was really impressed with what they're doing. Basically, this camera can be put on a line to identify bad parts. But here's the cool thing. The complete solution, everything is inside the camera. That's it. The hardware, the software, everything, the AI algorithms are all inside the camera. All you have to do is connect that camera to your network, and then you access the interface by typing in the camera's IP address in a browser. And an interface comes up and allows you to interact with the camera. Everything you need is there. You don't have to install software or know anything about AI algorithms or techniques to get this to work. And what you do is when you type in the IP address and connect to the interface, you upload about 100 pictures. Sound familiar? That's what BMW did, with about a 50-50 ratio of good pictures to bad. And then for each of the bad pictures, you simply identify the defect with just 2 clicks. And then you initiate the training, which only takes about 10 to 30 minutes for a basic application. And then bam, you've got reliable bad part detection. You put your cameras on the line and they can accurately pick out bad parts. And you get the camera, the software, the hardware, all the AI algorithms, complete turnkey solution. I think it was about 12 grand, and that was last year. I'm sure it's come down. There's so many solutions out there and coming out that are very similar to this. Basically, we are now providing artificial intelligence solutions for the masses, for you guys, at price points that are well within reach. But you might be saying, hey, you know what? I want to tackle this myself. Those are all good. I like what you said there, and those are some options we may consider. But you know what? I am curious about my data. I have access to all of my data sets. I have some technical resources in the company. We have a few people that work for me or with me that really love this stuff and geek out on this stuff. And I think I'd like to tackle this on my own. And here's the cool thing. Google and Amazon and Microsoft and some open source companies like H2O, they provide easy access to extremely powerful AI services and applications and capabilities for cheap. So with these tools, you can become very prescriptive and detailed and specific with your AI solutions. Now, it requires you to be fully hands-on. You have to understand the data, you have to understand the tools, you have to understand how to train the data and write those algorithms. And you often have to be comfortable with uploading your data sets to those services in the cloud. But if you want to do all that, you can build some powerful stuff. And just briefly, I'm going to go into some a little more detail on the options available from these 4 providers here. There's so many. I just want to give you an idea of what's available out there for you. Last year, Google consolidated all of their AI tools under a single platform called Vertex, and you can build and deploy and scale your models very quickly. It comes with a ton of pre-trained data sets. So if you find a data set that's similar to what you have, it's a great way to get a jump start on your project, and you can do most of that without code. Amazon probably is the broadest set of tools, but probably, to be honest with you, the most confusing to get started. When you go to AWS Intelligence, Artificial Intelligence, they have a plethora of services and frameworks and options, and can be a bit overwhelming to the novice. So I would recommend starting with their SageMaker Studio. It brings all those components into a single tool set. It's still a bit complicated, in my opinion, because I think Amazon, it's got a history catering to engineers and startups and developers, and you kind of see that in their tool set. So there's a little less hand-holding involved. Now, Microsoft is kind of the opposite as far as maybe where they are focused. They really focused on the enterprise, and they have a very strong set of tools that are really enterprise class. What you see on the screen here is the classic version of their machine learning studio. They do have a new version. You can probably figure that out by the name Classic. They do have a new version called Azure Machine Learning Service. It's more polished, it has better tools, but Classic is still very much capable. And it's what we built our initial machine learning projects in here at Plex. The reason I highlight it here instead of the new one is because you can test this out without signing up for a subscription. So, but they will be deprecating this in 2024, and none of the workflows will move over. So if you're already a Microsoft user with an Azure subscription, I would use the new learning services. And then finally, H2O. They're probably one of the biggest and well-known open source AI tools. They were built by makers with a mission to democratize data and make that AI available for everyone. So it can scale from your little project to an enterprise class project or product with full vendor support. Now, this is a cool slide. You should take a screenshot or type or copy down that URL that you see at the bottom. I'm not affiliated with Brillisoft at all. I was just really impressed with this article. For each of those 17 areas that you see on the screen in this slide, and I'm sure much of that list, if you're a manufacturer, much of that list resonates with you. For each one of those areas, this article goes into detail on how AI is being used in that specific area, along with real life examples, ROI, use cases, etc. It's really fascinating. In fact, I thought about just putting this slide up at the beginning of my talk and going to lunch and then having you read the article. But anyways, so knowing what you know now about AI and maybe the history and some of the things we've talked about so far, this is a great place to maybe incubate and your ideas and generate new ideas and kind of get some use cases, idea for use cases for your facility. Now you might be saying, hey, okay, this is cool, but I've never used any AI. I don't even know how it works in the real world. If this is all new to you and it all seems very foreign, the Data Science Dojo has this really cool simulator that shows you how AI and machine learning works. You pretend you're a passenger on the Titanic, and the screen asks you some simple questions about your age and gender and ticket class and people traveling with you, and then the model tells you what is the % chance that you will survive. As you can see here, I have a very small chance of survival. It's a bit morbid, I guess, but it is very effective. Although, and when I was using this, I was thinking, man, I'd love to actually replace this with something that was actually useful, right? None of us are going to be a passenger on the Titanic. And I was thinking of my own experience. I was thinking, if I wrote this I would love to answer the question like in high school, what are the odds that you'll get a date to the prom? And to ask you questions like, what's your favorite movie? How many digits of pi do you have memorized? Do you have a favorite pen? Here's all my favorite pens. Is there an action figure on display by your monitor? All mine are up there above the window, all my favorite Marvel heroes. And then it would give you a percentage of your chance of getting a date to the prom. But I digress, all right? Let's look at some takeaways. Our first big takeaway, the machines are not out to get you. They're here to help. Now, I know it seems sometimes like machines and computers and IT and all that stuff kind of makes your life miserable, but they're not doing it on purpose, and the benefits outweigh the negatives. Key takeaways. Remember, AI is simply automating pattern recognition at scale. The cloud has made AI accessible, and there are dozens, probably hundreds of use cases in your facility right now. Now, AI and automation are filling the gaps in a labor shortage, and you can get started with the people you have now, no data scientists needed, and the best AI in the world cannot overcome bad data. And our third set of takeaways, your RFQ should now include a question about AI. And there are compelling turnkey solutions that are existing now at affordable price points for all of you. And the last thing is big technology companies have smoothed the on-ramp for all of you do-it-yourselfers. All right. All right, that is the talk. I hope it was useful and entertaining and beneficial to you. And I think we're going to open it up for some questions.
Yeah, we do have a couple questions. Let me get to my question pane here. What is the difference between machine learning and deep learning?
Oh yeah, that's a good question, because you'll see those and in fact, I referenced it on that one slide with the retinas, and you'll see that often. And sometimes we use those terms interchangeably, artificial intelligence, machine learning, and deep learning, and maybe for our purposes that was okay, but to be technical, machine learning and deep learning are forms of artificial intelligence, and they're all hierarchical. So AI, artificial intelligence, is the broad discipline. And then you have machine learning, it's a subset of AI, and it relates to building machines or processes that learn patterns. But I have to give it the parameters and the data points and then train it. And if I come up with new data points, I have to manually retrain the model myself. Now, deep learning is a subset of machine learning. It takes that pattern recognition to a much deeper level. It uses complex algorithms and something called neural networks to mimic the human brain. And by doing so, it can actually retrain itself automatically. I don't have to do that. Sometimes it can figure out on its own what data points are relevant and what are not. So it is used to solve really hard problems in the AI landscape. Good question.
Okay. What are the best languages to practice AI?
Python. Python's one of the best languages. There is and a lot of the tools that you use from Google and Microsoft and Amazon will lead you down the right path there. But basically, Python is the main language to be learning. But if you have any, in my history or in my experience, most of the computer languages are very similar. And so if you do have experience in one, you'll be able to jump in pretty effectively.
Okay. What is the difference between AI and autonomous AI, and which would be useful in the future?
Oh, that's a good question. I'm gonna have to look that up. I can't remember off the top of my head, so I'm gonna have to pass on that. Yeah, I'm not sure of that one. That's a good question. It's just, I know autonomous AI is coming out. I just did some reading on that, but I'm not prepared to answer that one right now. Sorry. Good question.
Gotcha, they stumped you. All right, it looks like this one came through. My superior is suspicious of AI. He's heard some bad things online about data misuse and ethical concerns. What do I tell him?
That's a good question. So first of all, I would not dismiss their concerns, because you want your boss to be an ally in this, right? Their concerns are valid. There's a lot of things going on with AI that we have to be careful of. So we don't want the people, especially the people that are okay in our projects and handling the purse strings, we don't want them defensive about this, right? Kind of the worst thing that can happen here is your boss becomes the gatekeeper, feels like he's saving the company by saying no to AI. We don't want that. We want him on board, right? So remember that part about the results only being as good as your data. Well, that means if your data is slanted or it doesn't provide all the necessary facts, your results are going to be skewed. So that's why I can't emphasize enough having a data governance team, or at least a person or two that have full responsibility for building that model. And that team should be as diverse as possible. And I mean that both demographically and also their functional role inside the company, as much variety as you can get into that mix. You're going to have insight into how you're using your data that just one or two people might not see. And then I would invite your boss to participate. Make them part of the process. Let them participate and actually alleviate those fears by being part of the process and maybe helping actually make that project happen.
Gotcha. Okay, I'm not sure, Jerry, if you can answer this one or not, but I'll throw it out there. Are there any case studies I could refer to regarding warehouse layout efficiency improvements, product placement within warehouse? I don't know if that's in your wheelhouse.
Yeah, so we're not, yeah. You're just gonna have to do some searching on that. I can't help you on that. We're not really in the warehouse space, so I don't have any off the top of my head. So sorry.
Gotcha. Yeah, I didn't think so. I just thought you're a wealth of knowledge in several areas, so I wasn't sure if maybe you had that in your back pocket or not.
Yep.
And a couple people have asked, the recording will be accessible. Watch for a follow-up email to come out within the next couple of days, and we will have the recording of this webinar and that email. And it looks like all of the questions have been answered. Jerry did share his contact information, so feel free to reach out. And as always, check plex.com for any updates. And thank you, Jerry, for spending the afternoon with us. And thank you, everyone.
Yeah, and I would just, if I could jump in real quick. Go ahead. The autonomous AI, whoever asked that, send me an email and I'll get you an answer. I got some stuff right here. I just wasn't able to formulate it for this, but I can follow through on that.
Gotcha. Okay, great. Thank you, everyone. Have a great afternoon.
Thank you.